There are two fundamental types of general path objects. The difference between them is the winding rule that's used when determining which parts of an area are to be filled and which are not. When drawing the outline of a shape, it's a simple matter of drawing a line from one point to the next. However, when filling a shape, the general path is asked for every pixel whether or not that pixel is inside the shape. The question is not quite as easy to answer as you might think. You can look at it this way. When questioned about an XY point on the surface, it's like sticking a pin through the surface itself. If it doesn't puncture the shape, the return value is 0. If it does puncture the shape, the return value is 1. However, if the shape folds back on itself and it's punctured more than once, the return value is 2, or 3, or 4, or more. The winding rule determines which of these are considered inside the shape. Now, here's a program that shows you what I mean. This method, the getWinding method, creates a general path object that is shaped in such a way that it overlaps itself in one area. Don't try to figure out the shape from these numbers. I'll be showing it to you in a minute and it'll be obvious. Notice here in this line the call to the constructor of the general path. The rule passed into this method is used to determine what sort of general path we get. A general path is constructed here in the paint method, and this construction uses the wind odd even setting. That means that all odd numbers are to be considered inside the shape. For a pixel to be inside the shape, its number of punctures must be 1, 3, 5, and so on. All other numbers are outside the shape. Now, this winding rule has no effect on drawing. The outline of the shape is drawn as a bunch of lines, no matter what the winding rule. The fill rule, on the other hand, paints all the interior pixels. But a pixel is only considered interior if the puncture count is odd. Even numbers are considered outside the shape. A second general path is constructed, and this time the winding rule is set to non-zero. That is, if the puncture value is 0, the value is outside the figure. If it is 1 or greater, the pixel is inside the figure. And this has a direct effect on the way the second call to fill performs its job. Here's what happens. Here you see the three shapes. The one on top is a simple outline drawing of the shape, but you can see how it folds back on top of itself. The one in the middle is the one that's filled based on the odd-even rule, so there is no filling. Inside the shape, where it doesn't overlap, the count is 1, which is an odd number, so the pixels are all painted. However, where the shape runs back over the top of itself, the puncture count is 2, which is an even number, so it's considered outside and it's not filled. The bottom figure is filled with a non-zero rule, and all points outside the shape are 0, so they're left empty. All the ones with counts of 1 or greater are considered inside the shape, so they're filled. Okay, you may well ask why it's done this way. Well, I'm really not sure, except to remind you that Java comes from the world of Unix. And it's always been done this way in Unix. So, traditions die hard. It's sort of like that Microsoft tradition of referring to the main window as a desktop and then covering it with wallpaper.